Assalamualaikum. Today we proceed with the next topic, which is the normal approximation to the binomial. Previous lesson you have learned um, how to deal with the variable that have that are normally distributed. Okay, with parameter mean mu dan juga variance sigma square. And then you also know how to find the probability of the random variable using the standard normal table. Okay, so today kita tengok pula situation bila you kena approximate daripada binomial kepada normal. Okay, dari binomial kepada normal. Sebelum ni kita dah buat approximation daripada binomial kepada Poisson, kan? Ada syaratnya bila n large. Bila n large and p is very small, so kita approximate daripada binomial ke binomial ke Poisson. Okay, so ada another situation when sample size is large juga. Okay, at first our random variable is binomial distributed. Okay, at first ianya adalah binomial. Okay, tapi because of dia punya sample size is large and then dia punya p is close to 0.5 actually. Okay, ni dia cerita ni. Okay, dekat mana saya nak tunjuk? Okay, here. Okay, kalau baca kat sini dia kata, we now state a theorem that allows us to use areas under the normal curve to approximate binomial properties when n is sufficiently large. Okay, when n is large, at first our variable adalah binomial with parameter n dan juga p, which is the probability of success. When n is large, kita ada dua. Sama ada nak approximate kepada Poisson ataupun nak approximate kepada normal. Okay, if n is large. So, kalau p is very small, so kita approximate kepada Poisson. But, if p is, saya kata kat sini, p is not extremely close to 1. Okay, also provide a fairly good approximation even when n is small and p is reasonably close to 0.5. When n is large and p is not extremely close to 0 and 1. Tak adalah dia kecil sangat, tak adalah dia besar sangat value p tu. Okay, so kalau kecil sangat kita gunakan Poisson. Okay, so ianya sedang-sedang saja. Okay, maksudnya dia not close to 0 and not close to 1. Let's say your p is 0.4, okay, 0.6 macam tu. Ataupun bila n is small pun boleh juga approximate kepada normal. Tapi p is reasonably close to 0.5. Actually lagi nak senang, you kena ingat kat bawah ni ada actually dia cerita. Okay, here. Okay, approximation will be good if NP dan NPQ, NP and NQ, kan, NQ, probability of failure are greater than or equal to 5. Okay, you calculate nilai NP should be more or equal to 5 and NQ also more or equal to 5. Then kita approximate kepada binomial. Approximate kepada normal. Okay, approximate kepada normal. So actually at first our variable adalah binomial, but because of the condition is n is large and p is not close to 0 and 1. Also when n is small but p is close to half, ataupun kita kira you calculate n darab dengan p more than or equal to 5, n kena dua-dua, kena kira kedua-dua, and q more than or equal to 5. If these two condition is fulfilled, so kita boleh approximate daripada binomial kepada normal. Okay, so bila nak approximate kepada normal, kan macam biasa kita nak cari probability untuk normal, kita tukar dulu kepada z. Tukar dulu kepada z, which is the variable x tolak dengan sebelum ni kan, tolak dengan min. Okay, nak transform daripada X kepada Z, X minus dengan min, divide dengan standard deviation. So, sama juga konsep kat sini, X minus dengan min, divide dengan standard deviation. Tapi kat sini, because of X actually, yang asalnya X adalah binomial. So, kena kira lah dulu min untuk binomial adalah NP. Betul? Cek balik. And the variance for binomial adalah NPQ. So, X minus dengan min, which is NP, divide dengan standard deviation, which is the square root of NPQ. Okay, so if the variable is approximate to the normal, so kena transform kepada Z dulu. Okay, and then satu lagi syarat, kena buat continuity correction. Okay, dia kata it become apparent that if we seek the area under the normal curve, the left of C is more accurate to use X plus 0.5. This is correction to accommodate the fact that a discrete distribution is being approximate to the continuous distribution. Before this, bila you approximate daripada binomial kepada Poisson, tak perlu buat apa-apa correction. Betul tak? Okay, tetapi sebab Poisson is discrete, binomial also discrete. But now, because of binomial adalah discrete, tapi normal adalah continuous, so kita kena buat continuity correction. Okay, which is you need to plus or minus with 0.5. Contohnya dekat sini. Okay, because of NP more than or equal to 5 and NQ also more than or equal to 5. So, nak cari this probability, kita kena tukar dulu X ni kepada Z. Okay, kena tukar kepada Z. Bila nak tukar kepada Z, okay, as we know, you kena tolak dengan min, divide dengan standard deviation. But before that, kita kena buat dulu continuity correction, which is you need to plus 0.5 here. This one less than or equal to. Less than or equal to, it is plus. Okay, ada satu, actually dia ada punya ni. Okay, this is a continuity correction. If nak cari probability of X more than K, so kita kena tukar kepada Z. Okay, it will be more than K plus 0.5. Kalau more than, you kena tambah 0.5, tolak dia punya min, bahagi dengan standard deviation of binomial. Lah. Okay, if more than or equal to K, it is K minus 0.5. Kalau more than plus, more than equal, minus. Minus dulu dengan 0.5, barulah tolak dengan min, bahagi dengan standard deviation. Mu kat sini maksudnya NP lah. Sigma kat sini maksudnya square root of NP Q. Okay, kalau nak cari probability of X less than K, so it will be Z less than, tolak K minus 0.5 minus mu over sigma. Kalau less than or equal to K plus 0.5. Kalau less than, tolak, less than equal, plus. Kalau more than, plus, more than equal, minus. Okay. So, kalau X more equal to K, kalau nak cari probability of X equal to K, so kena tukar juga dulu kepada Z. So, it will be Z more than, okay, sorry, maaf. Bukan more than equal, more than sahaja kat sini. So, tak ada equal. So, kalau tak ada ke equal, Z more than K, maksudnya kena plus kat sini. Okay? Sebab more than plus. Less than, di sini minus. Okay, so that is the continuity correction that you need to memorize. Okay, we look at the example. Kat sini. Okay, the probability that a patient recover from a rare blood disease is 0.5. Ini adalah probability of success. Okay, recover, patient recover. P is 0.4. Dia punya variable X actually adalah number of patient recover from a rare blood disease. Probability of success, X ni maksudnya success lah. Probability of success is 0.4. If 100 people are known to have contracted this disease, so N is 100. What is the probability that the fewer than 30 survive? So first of all, you need to know you need to determine what is your variable. So variable kita adalah number of patients recover from a rare blood disease. What is the probability of success? Success ni maksudnya probability of a patient recover lah tadi, which is 0.4. And then the n is 100. Because of n is large, which is more than 30. Because of n is large, so kita kena approximate. So sama ada sekarang ni nak approximate kepada normal ataupun nak approximate kepada Poisson. So kalau nak approximate kepada Poisson sebelum ni, your P should be very small. But here P is 0.5. Lagi you nak check adalah you kira n darab dengan P berapa. Okay, 0.4 darab dengan 100. So you akan dapat 40. Okay, NQ pula 0.6 multiply 100. So you akan dapat 60. Both of this is more or equal to 5. Because of these two condition is fulfilled, so kita boleh approximate daripada binomial kepada normal. Okay, so daripada binomial kepada normal. So kalau nak approximate kepada normal, so we need the mean dan variance. So kena cari mean. Gunakan formula nak cari mean untuk binomial, which is n darab dengan p. So it is 40. Variance-nya NPQ, but kita nak sigma untuk buat transform. So the answer will be 4.899. So nak cari sekarang ni, nak cari probability that fewer than 30 survive. Survive maksudnya recover lah. So at first, actually kita nak cari probability of x less than 30. Nak cari probability of x less than 30. So because of kita buat approximation, so kena buat continuity correction. So daripada x less than 30, so nak cari probability, kena tukar kepada z. So because of a-nya adalah less than, so 30 tadi kena tolak dengan 0.5. Tolak dengan mean yang 40, bahagi dengan standard deviation 4.899. Sebab tu dia akan dapat kat sini. So, akan dapat probability of z less than negative 2.14. Okay, ni. Di sini. Cari probability of z less than negative 2.14. So, ni tengok dalam normal table macam biasa. So, ini juga okey, negatif kan sebelah sini. Kalau kita tengok normal table more than, ianya sama juga dengan more than positive 2.14. See probability of z more than positive 2.14. So, kenapa saya buat macam tu? Sebab kita nak tengok table ni. So, carilah 2.14. 4 kat mana ni? Sini. So, the answer is 0.01618. 0.1618 ataupun 0.0162 boleh lah. Okay. So, cari macam biasalah nak cari probability. Okay, look at the next example. Contoh. A multiple choice quiz has 200 questions, each with 4 possible answers, of which only one is correct. Okay. What is the probability that sheer guesswork yields from 20 to 30 correct answer for the 80 of the 200 problems about which the student has no knowledge? Okay, so semua sekali ada 200 question, each with 4 possible answer, of which only one is correct. So, nak cari probability sheer guesswork yield from 25 to 30 correct answer. For the 80 of the 200 problems. Of the 80 of the 200. Oh, okay, for the 80. 80 sahaja dia punya N. Of the 200. Semua sekali ada 200. Tapi dia nak dapatkan probability of the correct answer from 25 to 30. Okay. Correct answer. So, first of all, determine dulu what is your variable. Variable-nya adalah number of correct answer. Okay, sebab dia nak cari probability of correct answer. So the variable will be number of correct answer. So you need to know what is the probability of correct answer. It is 1 over 4. And what is your n? What is your n? N adalah, so dia kata, sebab dia kata for the 80 of the 200. So n is 80. Because of n is large, so kita kena buat approximation kepada Poisson ataupun kepada normal. Okay. So 1 over 4 adalah 0.25. It is not very small. So kita try pula n darab dengan P dan juga n darab dengan Q. Dapat berapa? Okay, so 80 multiply 0.25. You akan dapat 20, which is more than 5. And NQ adalah 80 multiply 0.75. Of course, you akan dapat more than that, which is 60. Okay, both of NP dan juga NQ more than or equal to 5. So, we can approximate daripada binomial kepada normal. Okay, daripada binomial 20 1 over 4 kepada normal, mean-nya kena cari n darab dengan P, which is 20, dan variance-nya NPQ, which is 15. Okay, right. So in order to make the transform, so kena cari mean dan juga standard deviation. Square root of 15, you akan dapat 3.875. So nak cari ni, probability of X. So, sebab kat sini X more than or equal, so sebab tu kat sini 24.5. Sebab tolak 25 tolak. Saya buat kat sini lah, boleh tak? Sebab saya perlukan panjang sikit. So it will be 25 minus 0.5 minus dengan 20 divide dengan square root of 15. Okay. Z. Okay, saya tukar Z tadi. Here will be 30. Because of di sini Z less than or equal. So, kalau less than, tolak. Less than equal will be plus 0.5. Minus mean divide dengan standard deviation. Okay. So, you akan dapat this. Dan cari macam biasa. Okay, Z ni berada di mana? Kedua-duanya berada di sebelah positif. Positif 1.16, positif 2.71, kita nak di antara ni. So, macam mana nak cari probability? So, kalau gunakan yang more than, maksudnya probability of Z more than 1.16 minus dengan probability of Z more than positif 2.71. Semua sekali kat sini, tolak yang sebelah sini, dapatlah tengah-tengah ni kan. Kalau nak gunakan less than table pun boleh. So, dia akan jadi 2.71. Semua sebelah sini, tolak dengan sebelah sini. Dapatlah yang tengah-tengah ni. Boleh kedua-dua table pun boleh guna, tak ada masalah. So, kalau this one, 1.16, 1.16, 0.1230, okay. 0.1230 minus dengan 2.71, 0.00336, 0.00336. So, you akan dapat jawapan yang sama, 0.11964. Alright? So, that is the way how you find the probability when at first your variable adalah binomial, but because of the condition n is large, and the condition NP dan NQ more than or equal to 5, so we can approximate kepada normal. But before we transform kepada Z, we need to do the continuity correction. Depends pada you punya apa dipanggil inequality, sama ada more than ke, more than equal, less than or less than equal and so on. Alright, so kena tengok macam mana nak buat continuity correction. Okey, dan satu lagi actually adalah approximation juga daripada Poisson kepada normal. Dalam dia textbook tak ada, tapi ada dalam kita punya syllabus. Daripada Poisson nak tukar kepada normal pula. Sebelum ni, binomial ke Poisson, binomial ke normal, dan satu lagi, Poisson ke normal. Okey, Poisson ke normal sangat senang. Kita baca sikit. A discrete random variable x is said to have the Poisson distribution with parameter mu. Kan, kita akan tulis biasanya untuk Poisson. X will be the Poisson with parameternya mu ataupun lambda, okay, which is the mean of that random variable. However, if and only if mean ataupun lambda is more than or equal to 20, if and only if, the Poisson distribution can be approximate kepada normal distribution. Okay, daripada Poisson nak approximate kepada normal. So, kalau normal, kita perlukan mu dan kita perlukan sigma square. Okay, which is, so dia akan jadi mean untuk, so kat sini kita cari mean untuk Poisson lah. Mean untuk Poisson adalah mu ataupun lambda. Dan variance untuk Poisson is also mu ataupun lambda. So, we put that. Ataupun boleh juga lah nak guna mu. Mu. Okay, this one. Okay. So, sama juga. So, sekarang ni nak cari probability kena guna this distribution dah lah. Tak boleh lagi gunakan Poisson mu parameter. Okay, and then once again here, because of Poisson adalah discrete dan normal adalah continuous, kena buat juga continuity correction yang sama. Macam tadi juga. Okay, let's say, tengok example kat sini. Suppose the number of babies born during a day shift at a hospital follows a Poisson distribution with mean 6 per hour. What is the probability that during a particular 4-hour period, less than 20 babies are born? So, kita punya random variable kat sini actually adalah number of babies born in 4-hour period, which is the mu adalah 4 multiply 6. Sebab 1 hour, 6 babies born. So, in 4 hours, it is 4 multiply 6, which is 24. Because of 24 is more than or equal to 20, so we need to do approximation kepada normal. So, kena tukar kepada normal with mean-nya adalah mu, which is 20, dan variance also 20. Okay, so sekarang nak cari probability of the probability of less than 20 babies are born. Less than 20. So, this one less than 20. Because of this is less than, so kena tolak dengan 0.5 dulu. Baru tolak dengan dia punya mean. Sorry, not 20 here, 24. Minus mean divide dengan standard deviation. Okay, sama juga. Sebab less than, so kena tolak. Kalau less than equal, kena tambah 0.5. So, macam biasa cari guna table. So, kat sini, less than negative. So, nak sebelah sini. So, sama juga dengan more than positive value. Okay, so tengok macam biasalah 0.9. 0.92. The answer is 0.1788. Sorry. 0.1788. Okay, let's see another example. Recent crime reports indicate that on average, 3 motor vehicle theft occur each minute in the urban area. What is the probability that at least 20 theft in 9 minutes? So actually the variable adalah number of theft in 9 minutes, which is dia punya mu adalah 3 in each minute. So, in 9 minutes, 3 multiply 9, which is 27. Okay, because of 27 is more than or equal to 30, so kena buat approximation kepada normal distribution with mean 27, variance also 27. So, sekarang nak cari probability at least 20 times in 9 minutes. So, nak cari probability of X, paling sikit pun 20. So, more than or equal to 20. So, because of more than or equal to, first of all, nak tukar kepada Z, 20 ni kena tolak dulu dengan 0.5. Kalau more than, tambah. Kalau more than equal, kena tolak. Okay, and then minus dengan its mean, divide dengan its standard deviation. Okay, so berapa dapat? So, akan dapat negative 1.44. Okay, so sebelah mana? More than negative. Di sini negative. So, kita nak semua ni. So, maksudnya 1 tolak probability of Z less than negative 1.44. Okay, so less than negative 1.44 sama juga dengan Z more than positive 1.44. So 1 tolak 1.44, 0.0749. Okay, so the answer is 0.9251. Okay, so that is the way how you calculate the probability when involving the approximation daripada Poisson kepada normal. Okay, so that's all. So remember lah ada 3 approximation, binomial ke Poisson, binomial ke normal dan Poisson ke normal. Untuk Poisson ke normal dan binomial ke normal yang you kena buat continuity correction. Okay.